Hi, I'm James Williams and welcome back to my channel. So this week I submitted my first ever sample to the Power Platform Sample Solution Gallery. It turns out this was the 50th ever sample submitted to that gallery, so really lucky and grateful for my first sample here to have helped the community reach this fantastic milestone. So here's my sample in the Power Platform Samples Gallery. So my sample is a component, a Power Apps component. In this case, that lets you select a color from a grid. So you might be familiar with an interface like this from applications like Microsoft Paint, where you don't select immediately using the red and green and blue values of a color because that maybe isn't as natural to do. Whereas in a grid like this, you can see the kind of color you're going for, and then once you've hit it, make some adjustments, select the correct lightness for that color, and then away you go, and those red, green and blue values are selected for you. So I've tried to replicate that in my component here, and I thought in this video I'd talk you through how I've done that. So here I am in the Power Apps Studio, and here's the component in place. You can see it looks a lot like that one from Microsoft Paint, where you can select a color in this grid, and then you have a lightness selector down the side. And when you've selected a color in here, it selects the relevant red, green and blue value in the Canvas app here, so that you can use that elsewhere in your app, as in this example, in order to set the color on some other control. So as this is a component, you can see here that it's got some input properties. So there's the number of rows in the grid, as well as the default color, which is what it should be selected from the outset, and obviously you can update that in your app, as I have done here. And then the other part of it is an output property. So you can see here that this apply chosen color button applies this chosen color output property of the component to this variable var color, and that's what sets the color of this block here. So to have a look at what's going on in this component, if we move over to the component tab here, this is where the component is designed. You can see that there are those input properties, the rows and default color, so they're of type number and color. But there's also a selection here of another type of property, and these are a function type property. So if I click on that, you can see there that these type of properties can be called as a function with parameters. So at various points in building this component, I've captured some logic in these functions, which I've then used elsewhere in the component, which helps to divide up the logic used in this app. Now, function type properties need to be enabled. If you go into updates here, they've actually graduated, it seems, this week into being a preview feature rather than an experimental feature like they were when I built the component. But as long as you've got this enhanced component properties set on these additional property types, function and action, they'll be there for you to use in your component. So let's first have a quick look at the controls used in this component. So the main part of the component is this grid of colors, which is built using just a simple nested gallery. So the outer gallery, which is one for each row. So this is all the rows, which is, as you can see, as we're getting down in the grid here, it's getting less and less colorful. This is where you choose the saturation. So the more saturated a color is, the more colorful it is. So that's why this top row here is the most colorful of all. This is kind of the pure colors. And then within each row here, there's another gallery, which is a horizontal gallery this time, of each hue available to be selected. So the hue is like a spectrum of all the colors. So that's why it goes all the way from red to almost back to red again at the end here. And then within each of those items in this gallery, it's just one rectangle which is colored with the color that we want to display and allow a user to select. So that's the main grid. And then on the right hand side here, we've got one gallery, so not a nested one this time, just a gallery of some more rectangles. And in this case, it's the lightness. So between the three galleries here, we've got a way of selecting each of the values for the hue, saturation and lightness, which is how the Microsoft Paint way of selecting a color works. And then that's then converted into the perhaps more popular RGB, red, green and blue way of defining a color. And then, so as I select a color here and I select a lightness, there's a block here, another rectangle that shows the selected color, the final output color, and then on this side just a label that produces the red, green and blue number values and the hex version of that RGB color. So if we first take a look at the saturation gallery, the outer gallery of this grid, we can see that the items property of that gallery is being determined by one of these functions. So inside that component color picker there is a property which is a function type property called color table, which is outputting a table, which in this case is a row, a table of rows, and each row will have one of these color definitions in it. So if we go over to the component to have a look what that looks like, if I click on color table here, have a look at the formula. So this is an example of a function that doesn't have any parameters, whereas some of these ones we'll look at later do have parameters. This is just a pure function. You call it and it gives you an output. So in this case it is a nested for all. So it runs through two sequences here, one to generate the saturation values and one to generate the hue values, and then the output is a grid of these objects that have a hue, saturation and lightness property. Now lightness is just set to half, which is halfway down this lightness selector on the right hand side, because that's the most colourful choice, so that's what we want to appear on this grid on the left hand side, and then the user will select the lightness that they want output from the components using the selector on the right. So we've set that manually to 0.5 at this point, and then the hue values will be picked, and using these formulas here, that means we've got all the hues starting at 0, which is red, over to nearly 1 at the end here, which 1 will be back at red, going the complete way around the spectrum. So we've got all but one step towards 1 here. And then in terms of the saturation, we start at 1 at the top of the gallery, which is the most colourful you can get, and then less saturated all the way to grey, which is 0 at the bottom of the grid. So in both those cases, it's looking up the rows input property of the component, which was, if I open the properties back up, set to default 9, which is why there's 9 here in this component. But in my demonstration, I've got 15, which is why there's more rows in the grid available in the demonstration than in the default value inside the component itself. So the items input to the saturation gallery is that whole table. So table of rows, and each row is going to be this item.value, which is the input to the nested gallery inside of that. So in here, this item.value will be a collection of those hue, saturation and lightness properties within objects. Each one will refer to a particular color. So the next question is, how do we use those hue, saturation and lightness values to set the color, the fill color of these rectangles in the nested gallery? And the question arises because PowerApps doesn't work with hue, saturation and lightness. It only works with red, green and blue colors. So normally you'd see an RGBA function where you can set those red, green and blue values as well as the transparency of the resulting color, and use that to set a color for any control with a color property in Canvas apps. However, we've only got hue, saturation and lightness, so we need to be able to convert, which we do here using a function property of the component. So I've just called it HSL to RGB, and this time we've got some parameters to the function. So I'm passing through this item's H, S and L values, and the output of that is another object with an R, G, a B and an A property that I've fed into the RGBA function, and that produces a color that PowerApps can then use. So that function is defined back in the component here, HSL to RGB. So we have a look at quickly the definition of that function property. let's see, a function type. It's an output property, which does mean that this function could be used in the app which uses the instance of this component. But for the purposes of the component, I've only used it internally to the component, and it produces a record, and each that record has those RGBA values output, so they can be used elsewhere in the component. Here's the important bit. So we have 3 parameters. So I click on H here, so that's hue. I've just called it H, but that's a number, so it's expecting a number here. It's a required parameter. Same for SNL, we've got some required numbers. So when I define how this function works, I'm going to take in those 3 parameters and produce the RGBA values as the output. So you can see how I've done that here in this function. If I make this a bit bigger, what I've actually done here is I've adapted a function, because I'm not an expert on colors. I've adapted a function I've found on Stack Overflow. So if I open this tab, you can see someone's asked the question before, how do I convert HSL to RGB? And some clever person here has produced not only the HSL to RGB function, but the reverse, which we'll use later on, to convert an RGB color back to HSL. But these functions are in JavaScript, so needed to be rewritten into PowerFX to be used in the Canvas app. You can see here at the bottom there's a little helper function, hue to RGB, which is used within the overall HSL to RGB function. So for each of the red, green and blue values, it actually uses that helper function with some different parameters. So we'll need to copy that into the Canvas app logic as well. So here back in the studio, this is what those functions converted to PowerFX look like. In the case of this one, I think I started by asking Copilot how I would convert one to the other, and it got pretty close. I had to do a little bit of tweaking to make things work and to keep it as simple as possible. But this is now pure PowerFX rather than JavaScript, and you can see, just like in the JavaScript code, it's using that helper function 3 times, hue to RGB, which is another function type property. So if I click on that, you can see that's expecting a P, a Q and a T parameter, similar to the HSL one. And if I click on that one, it's defined like this, so very similar to the JavaScript there, except that you can see in the JavaScript, what JavaScript's able to do is amend this value as it goes through the function. So T started with a particular value when it was input to the function as a parameter, but then depending on these Boolean expressions here, it actually changes T before it gets to this lower part. We can't do that in Power Apps. So what I've done is I've used a with function here to use a capital T instead, to, depending on those same Boolean conditions, change the value of the lowercase t to be the uppercase T output, and then it's that uppercase T that's used further down. So slightly different approach used in the PowerFX than it is the JavaScript, but the end result is the same. So if I go back to look at HSL to RGB, we can see that the output is another object with properties, so an RGB and an A property, which I've just set to 1 because I'm not dealing with transparency here. But those RGB values are determined by those input HSL values and the result of these functions. So that will give me the RGBA values I need to colour those rectangles in the grid. So once you've selected a colour in the grid there, the onSelect for the rectangle fires, and that sets a variable to the current item. So that determines the desired hue and saturation, saves that to a variable var selected, at which point the lightness gallery on the right here updates to show the set of lightnesses for that color. So the items property here, rather than using a function, is just another case of going from maximum lightness to 0, so 1 to 0. And then this rectangle's fill is set in a very similar way, except this time we have the lightness value. It's not that predetermined 0.5, it's whatever has been selected here. So that's how it knows how to color each of these rectangles. And then when one of these is selected, the output box rectangle here at the bottom uses a function chosen color, and it uses a function because that's sorry, not a function, the output property, and that's because that is the output property given back to the app for the application to do something with the color that's chosen in the component. So if we look at chosen color, all that's doing, very similar, is using HSL to RGB with the var selected H and S values, and then the currently selected lightness value from the lightness gallery, and that turns out an RGBA set of properties, and we put that into RGBA, the built-in function, and that gives the property to the output property chosen color, which is then usable in the app. And you might wonder why all along I haven't been outputting colors rather than just the way I've done it, which is having objects with RGB and A values. And the reason is the other part here of the component is this bit that displays the individual RGB and the hex values, and it couldn't do that if it was taking in a color. So this interpolated string here that's shown in this text label pretty much just shows what those RGB values are to the user, and then a new line, and then using dec to hex, the built-in function, to convert a decimal number to hexadecimal with 2 padding in each case to make sure they're always 2 digits long. That's what turns those RGB values, which are 0 to 255, into this hexadecimal at the bottom. So you might have noticed that there's 2 functions and I've not got to yet, and what they might be for. And they're used in order to take this default color, which is provided from the outer application to the component, to take that color and use that to select the starting color in the grid and the lightness picker. The problem is the default color could be any color with any value of red, green and blue from 0 to 255. There's a lot of possibilities, and rather than 255 rows in this component, we've only got 9 by default, or whatever you picked in the rows property. So that exact color that's provided to default color might well not be in this grid and in the underlying lightness picker. So what I've had to do is come up with a way of not only converting the incoming color from RGB to the hue, saturation and lightness used in the grid, but then also coming up with a way of finding the nearest of those colors in the grid to the selected default color. So if we go to the saturation gallery and have a look what the default property is, it's looking up from that color table, var selected, and it's saying, is that record in the current value? So how is this var selected set to the closest color, to the default color? Well, that's actually done by virtue of the default color property being told to raise the OnReset event of the component when it's changed. So when it's first loaded, and then when it changes from the outer application, this will trigger the OnReset event of the component here. So let's have a look at this. So the first thing going on here is to deal with the fact that it's a color coming in as the property and not those individual RGB values. And there's no way of taking a color in Power Apps and just getting those RGB values out of it. So what I've had to do is convert that color into JSON and then back out into a string using parse JSON and telling Power Apps that that's a text string. And then I look at the individual elements of that string, take the values and convert them from the hex codes. So it comes in a code like this. So it takes the relevant digits and it converts them from hex to decimals. So the output of these will be the red, green and blue values that we're used to seeing for RGB colors. And then the next thing we do is we take those output values and we're passing them into this RGB to HSL function. So very similar to the other function where we've taken it from Stack Overflow and we've converted it into PowerFX. Don't think I asked Copilot about this one. I think I just used what I'd learnt from the previous function conversion and did it myself. But this is what I came up with for the the function that was on Stack Overflow, and then that's used in that OnReset property in order to determine what the default color is in the HSL format, which then gets put in this var default color HSL variable. Then what we do is we create some more component variables which represent the possible values for the saturation, lightness, and hue. For saturation and lightness, this is what we've seen before in the app. So all the possible values from 1 to 0 divided into the number of rows. That's the same for both of those, so they're set in one variable here. And then H is slightly different. That starts at 0 and goes almost all the way to 1, but not quite. So they're all the possible values that could be in those three properties. And then we move on to determining what the closest of those is in the so what the closest color in those possible values is to the default color that's been input to the component. So to do that, we've used another function here I've called the function nearest number, which takes those possible input values as well as the value we're looking to get the closest to, which in this top one here is H, the hue, and this function returns the nearest number in the input table to that second parameter. So in this case H. This will give us the closest hue in the grid to the default color's hue. And the way that nearest number property works is, again, we've got two parameters input here: a number table, which is a single column table of values, and the target number. And then you can see if I click on the definition, this is how it works. So it just finds all the differences between the target and each of the values in the table, and it sorts them so that we know the first of those, which is the closest to the target number. And one thing I had to figure out how to do in building this to get it to accept the dot value as the definition of the table schema that's input to the number table property is that in the drop down you can also see under and slightly indented to nearest number is a number table here. So just by providing a set of numbers here, I'm telling that function property what schema I expect to see for that parameter that's input to the function. So it knows here that it's just going to get some numbers, and doing it in this format means it's going to be a table with a single column called value that's then used in the nearest number definition in the absolute function here to find out what the difference is, and then all the way back in the OnReset property of the component that will set those H and S values in var selected. And in the case of var selected, we only set lightness here to a half, and that's because that's what is shown in all the colors in the grid, because the lightness is then selected on the right hand side by the lightness picker. So again, we have to go through a similar exercise of finding the nearest number to provide the default value to the lightness picker. So then we've got the closest number in the grid to the default color, and we've got the closest lightness in the lightness picker to the default color as well. So that set the default value here in the grid, and then on the right hand side in the lightness picker we've also got the default value. And the reason for this condition here is once a user selects a color on their own, no matter what the default color was, the lightness is then set back to 0.5 to match the color in the grid, and then that allows the user to either take that color and just use the most colorful version or change the lightness themselves. So it's only where a user hasn't selected themselves that it then uses the var default L value to set the default. Otherwise, it just gets the item halfway down the list, which is the closest to 0.5 the lightness picker can get. And that's it. That's how the component works. So if you want to give it a try for yourself, head over to the sample solution gallery, and in the solution folder here's a zip file you can import as a solution into your Power Platform environment, which will provide a component library from which you can use the component in any of your Canvas apps. So please do consider submitting your own samples to the solution gallery, and hopefully they'll get all the way to 100 before you know it. So if you've enjoyed this video, please consider dropping a like and subscribing to my channel. Otherwise, all that leaves for me to say is thank you very much for watching, and see you later at Maker.